So we got one more part of the practice test to look through, and that's the names and the angle measures of the different polygons. Now, polygon names have been given for many years, and so we're going to go with the ones that have been given to us, and we just have to, it's part of learning geometry is learning the language, and so I'm just going to go through the names first. Of course, I think we most know that this one is a triangle. And the next one is a square, but more common name for it could just simply be a quadrilateral. Quadrilateral. There we go. That's an A there. Quadrilateral, 4 sides. And then the next one with 5 sides is a pentagon. And then with 6 sides we have a hexagon. And then 7 sides is actually called a heptagon. And with 8 sides, your classic stop sign shape is an octagon. And then there's some other ones bigger than that. When we get up to 9 sides, there's several names for this one, but we're going to use the more common name that we say nonagon. And then if you want to go up to 10 sides, if we were talking about 10-sided, it would be, just add this on here, 10 sides. This is really what we should know through is a decagon. And there's lots of other multiple-sided shapes, but after 10 sides decagon, we pretty much just say how many sides it has. There are names for them, but they're not as well known. But these are more common shapes that you see in the real world anyway. So those are the names for the different shapes, starting with the triangle, with the 3-sided, and then the 4-sided, and so on. Now to find the individual angle measures of them, you really need to know the total angle measures. And for a triangle, we know that a triangle, all the angles always add up to 180 degrees. We've kind of tested that a number of times in different activities, and we see that no matter what the triangle size or shape is, it always adds up to 180 degrees. So if you want to find the individual angle measure, if you know it adds up to 180 degrees and you know you have 1, 2, 3 angles, you just take 180 divided by 3, and you get 60 degrees for each of those angles. So now the question is, well, how would you know for a square? Well, a square is actually pretty simple because these all look like right angles, and they're all 90 degrees. And so really I have 90 degrees times 4. The individual angles are 90 degrees. Sorry, that's the wrong space. And then let's cross that out, move on. But the total angle measure, really, if you think about it, is really just 2 triangles worth. Because if you think about a square, you could cut it up into 2 triangles. And you know that a triangle is 180 degrees. So if I have 2 triangles that are 180 degrees each in their angle measures, you take this one and that one, and they add up to 180. And then this one and that one and that one, and they add up to 180. And so the total there is going to be 360 degrees. And really, you can use that for every one of these shapes. If you can't remember the total angle measure, all you have to do is remember triangles. Triangle is the key. So if I take this pentagon and I divide it up into triangles, I can make it into 3 non-overlapping triangles. I don't want these lines to cross somewhere. I want them to be separate, so I can make separate triangles from side to side of the pentagon. So I have 1, 2, 3 triangles, and each triangle is 180 degrees. So 3 times 180 is equal to 540 degrees for the pentagon, for the total angle measure. And now if I'm stuck and I don't know how to find the individual angle measures, I know that there's 1, 2, 3, 4, 5 angles in a pentagon. So if I take that 540 and divide it by 5, then I will get the angle measure for each individual angle, which is actually 108 degrees on a regular pentagon. Each one of those is 108 degrees. 108 degrees. There we go. So, and I can move on to the hexagon and I can do the same thing. And again, if I'm stuck and I can't remember the actual angle measures and what they add up to, I can think of it as a bunch of triangles. One triangle there, and another triangle, and another triangle. So now I have 1, 2, 3, 4 triangles. And so now I have 4 times 180. And if I do that, I get 720 degrees for the whole thing. And again, if I'm stuck and I don't know the individual measures, I haven't memorized them, I can take the 720 and divide it by the number of angles, which is 6, same as the number of sides. And I'm going to get 120 degrees for each of those angles. So all I did was divide it into triangles. 4 times 180, because each triangle is 180 degrees. And then once I got my 720, I just divided it by the number of sides or angles, because there's the same number of sides and angles. And that gave me my 120 degrees. For the individual angles measures 120 degrees in these corners here. Okay, now, moving on to the heptagon, 7 sides. So let's see how many triangles I get. 7 sides, I get 1, 2, 3, 4 lines, but there's 1, 2, 3, 4, 5 triangles. So I've got 5 times 180, which gives me 900 degrees for the total measure. And this one's kind of interesting. When you divide it, 900 divided by 7, you get a decimal answer, 128.57, and we're just going to round it off to 0.57 at this point. It really could round off to 0.6 for the whole thing, but it's a little more than 128.5 degrees for the heptagon, for the individual measures. And then the octagon, 8 sides. So again, if I couldn't remember what's going on here, and I can just take the time to divide it up into triangles. 1 there, 2, 3, 4, 5, and really there's 6. So 1, 2, 3, 4, 5, 6 triangles. So 6 times 180. And you can use a calculator on this. So I'm not just memorizing these, I use a calculator too. So 6 times 180 actually is 1,080 degrees for that one, for the octagon. So the total is 1,080, and if I take 1,080 divided by the number of sides, then I get the individual measure of 135 degrees for each of those angles. And I can do this for any size shape. Now, down here I don't have the picture of the nonagon, 9 sides, but one of the things I've noticed is that with the octagon, 8 sides, there's 6 triangles, and with the heptagon, there's 7 sides but 5 triangles. And this one is 6 sides but 4 triangles. So one of the things I noticed is it's always 2 less. 2 less, that's 8 and that's 6, 7, 5, 6, 4. Even this one is 5, 3. There's always 2 less triangles than the number of sides. So even with the nonagon, without having to do that, I can take the 9 minus the 2, and so I'm going to take 7 triangles, and I'm going to take 7 times 180 degrees, and it's going to give me 1,260 degrees for the whole thing. And if I want to find the individual measures of each side, then I'm going to take that 1,260 divided by the number of sides, which is 9, and that will give me 140 degrees for each individual angle of the nonagon. Or however many sides I have, I can use the same system to find the total degrees and the individual degrees for regular polygons. These are regular polygons because their sides are all the same length, and so we can find the angle measures for them. If they weren't regular ones, it would be a little bit more difficult to do that, but we could still find the sum or the total angle measure for any polygon using this system. And that really is all you need to do for geometry for this test.